Hello, ladies, gentlemen, and non-binary, and welcome to all our fearless females today. Happy International Women's Day. Thank you for joining us for today's webinar, partnered with Digi-Key Electronics, the exclusive sponsor of the Würth Elektronik webinars. I'm Amelia Thompson. I'll be your host for today's presentation, Introduction to Wireless Power Transfer, with our very own David Martin. He's a project marketing manager for wireless power transfer at Würth Elektronik. David, thank you for joining us today.
Thank you for the invitation, Amelia.
Yeah. Now, if you have any questions during today's webinar, feel free to ask them in that questions box. You can test it out. You can say hello to myself, and then our presenter will answer them at the end of today's session. Now, if your questions don't get answered, maybe think of them a little bit later. If they are very technical and you need more details, then simply email us at webinarteam@we-online.com. Now, because you registered for today's webinar, you are automatically going to receive an email. In that email will be a link, and it's for the presentation slides as well as the video on demand of today's webinar. And again, that email will come from webinarteam@we-online.com within the next week or so when the video becomes available. Don't miss our next webinar coming up in a week on the 15th as we continue our lesson on wireless power transfer with Advanced Wireless Power Transfer course, again on March 15th. Register online at www.we-online.com/webinars. And now let's begin today's Würth Elektronik webinar with David Martin, and it's the cord Introduction to Wireless Power Transfer, partnered with Digi-Key Electronics.
Great. Hi, everyone. Many thanks for the invitation. And I will just share my screen. Okay, so all okay for everyone? Thank you very much, Amelia, for the introduction there. As Amelia says, my name is David Martin with the Wireless Power Transfer team with Würth. You can see the range of components there that we offer. And this is the introduction. This is the basics course on wireless power transfer. Thank you for your interest in wireless power. There's some great products out there. There's some great opportunities, and hopefully we will see them as we go along in this discussion today. This is the basic course, the introduction. We'll cover a number of applications just to show what is possible with wireless power. And then we'll review some of the technologies and the standards that are in wireless power. And then starting to think about implementing a design with what are the specifics of a coil consideration, and what products and components that Würth Elektronik offer for you that will help you as you try to implement a solution. I'd like to introduce this topic by thinking about, the days that we used to go to visit customers, and we used to go to conferences and trade shows and go on holiday. And we dropped out there. Dropped out. Oh, sorry. And we used to go on trade shows and conferences and visit customers, and your suitcase would be full of cables and power supplies and 3-point plugs and 2-pin plugs and USB connectors. And you would turn up at the customer site, and you'd spend the next 10 minutes crawling onto the desk trying to plug in your devices. And then you'd stand up and present, and your laptop would be saying, "Oh, low battery warning." And really, wireless power attempts to address all those issues, all those cables that you had to carry with you wherever you went. And Würth Elektronics, we say we cut the cord as our brand to show that we're trying to do away with that mass of cables that you used to have to take with you when you travel. And wireless power transfer, I guess it's the new up-and-coming technology, but it's been around for quite a long time. If you've seen the Netflix film Edison in the 1880s, there's discussion about the best way of delivering electricity, and Tesla was there with demonstrating the first wireless power transfer method. But really, it was into the 1980s before a product that really made use of that technology, with the electronics that developed, the MOSFETs developed, to allow that electric toothbrush that you have in your bathroom as the product, maybe the first main product with wireless power transfer. And then as mobile phone technology ramped up, and people realized they needed to have a standard protocol safety. And that was the start of the Wireless Power Consortium and other groups that were trying to define a standard for power transfer. And then the smartphones were introduced. And really, just like as in Tesla in the 1880s, there was that competition, which is going to be the most successful power transfer method. And really, when Apple joined the Wireless Power Consortium, the WPC, in that year, really that was the technology clear, that Qi standard 5 to 15 watts power transfer, closely coupled induction transfer as the way forward. And development continuing beyond mobile phone technology, going up to electric vehicles with 11,000 watts of power for battery charging. And we mentioned some applications there, but really just to review some applications. Just that you know, this may be a first time for you, but just to let you know, you're probably already using wireless power transfer in your home already. I mentioned there the electric toothbrush, and you see in the top left corner of the picture there, you see the charger plugged into the mains. That's what we call the transmitter, the charger, the base station. With your mobile device, that's your electric toothbrush. On the right-hand side there, you have earbuds that are charged within the charging box. And on the bottom left there, you've got like a cordless kettle, to 2.2 kilowatts, a charging station that's plugged into the mains, and your mobile device, your portable, your cordless device. And in the bottom right-hand corner is like the charging station that you might find maybe in a coffee shop, maybe in an airport lounge, maybe on your bedside light, a charging station where you can put your smartphone down and it can be charged off that charging station. And this picture illustrates many of the things to do with wireless power charging. First, you can see the big range of devices that are there. From the earbuds, they're probably 1 watt or less power, very small size, very low power. The mobile phones there is in the 5 to 15 watt range. The kettle, in the future, there'll be a cordless kettle with 2000 watts power range. So big range of sizes, big range of power, all with them with the core technology of a transmitter that's plugged in maybe into the mains and a mobile device. And the 3 devices which are to the top left of this picture, you can see that the mobile device has its own dedicated charger. I mean, you couldn't imagine plugging your toothbrush into your cordless kettle there. So each device has its own dedicated charger, designed one-to-one to fit each other. By contrast, the phone charger in the bottom of the picture in the bottom right-hand corner is designed to be universal, so that whatever type of smartphone you bring along, it can be charged off that common charger. And the same for other consumer portable devices, 5 to 15 watt power range. So this picture illustrates many of the things that we'll talk about further. And this is 5 to 50 watts consumer devices. And now that has become established, then wireless power technology has moved into these other areas. There's industrial, and you can imagine robotics or drone technology, industrial applications. Medical technology, because wireless power is a perfectly sealed device, no metal contacts, no ports, it can be very clean, hygienic, and suitable for medical technology. In the top right is automotive wireless power moving from maybe 15 watts of a phone charging to electric vehicles up to car charging. And furniture infrastructure, maybe like your bedside lamp that has a phone charging station built in, or maybe a conference table that has charging stations built in for your laptop. So furniture infrastructure being built in for wireless power charging. Just to illustrate some examples here, I mentioned there medical, hospitals, operating theatre, very hygienic, very clean, sterile environments. And here you see the remote control with a sealed wireless power unit inside. So it's completely sealed, white, clean, hygienic. And the cross-section picture on the left, you have to break away the plastic to see the coil inside. It is completely sealed, encapsulated to make that clean, hygienic environment good for hospitals, operating theatres. Another medical application, this is for severe hearing impairment. There may be a device in the patient's skull underneath the skin. And that device, well, you obviously don't want to take the device out and change the battery, but the battery can be charged wirelessly with this attachment here. And that was human medical considerations. Here is also in animals. This little gadget is connects to the animal's skin, maybe measures heartbeat, body temperature, oxygen levels, can be measured by sensors. The device powered up wirelessly, and maybe data being transferred back to the animal owner or to the vet, maybe an animal under treatment. Demonstrating wireless power transfer and how also data can be transferred back to an office, to a vet or an owner. Another personal device for those of you who play I don't know, ice hockey or rugby or American football, big contact, big collision sports, and you always put in your mouth guard to protect your teeth. Here, this considers excessive an impact, excessive movement of your head, which could be an element of concussion, could lead to concussion. And here, this device indicates of excessive movement and accelerometer, and it flashes a warning back to say attention needed. And this device is sealed within the unit, puts into your mouth. It's perfectly clean, white clean, and it's wireless power transfer to charge up that battery that's in that device. And me, I dropped my phone in the snow in the mountains one day, and the phone never worked again. Moisture, snow gets into the ports, into the connections, gets into the electronics, and my phone never works again. If you're in the snow skiing and you have I don't know, danger, you have an avalanche, you're covered in snow, you want to make sure that your device that says "come and rescue me" is working, and wireless power provides this totally sealed unit, moisture damp proof, so that the device is guaranteed to work without risk of moisture ingress, and the battery inside that device is charged then wirelessly. So a great safety device, demonstrating that wireless power allows that completely sealed unit. This device here is obviously going up mountains. On the other side, this is going down into the depths, so that if you were a diver, here's a diving computer. It's showing here, for example, the depth that you've dived to, your time under your water, and again, completely sealed unit, no moisture into the unit, and the battery in that diving computer is charged up wirelessly by the device that's on the left there. Those are consumer devices, maybe with the 5 to 15 watt range, and other developments are going up into higher power ranges. The Wireless Power Consortium has been working on the cordless kitchen for a number of years, getting closer to being the spec being finalized and products coming to market. They have this logo there, KI, it's kitchen key, so that one common charger unit, maybe on the workstation, to be used to power up kettle and then air fryer, blender, mixer, microwave, from that common charging point, working in a similar way to an induction hob. Another big development area for wireless power is this industrial applications. There's maybe you see pictures on the news of drones being used to deliver packages, just like illustrated there. There on the right, there's a factory installation with robots, maybe being for delivering things around the factory, and similarly a robot delivery system in that picture on the left. Another application area is vehicles, and this area is the light electric vehicles. That's maybe power levels up to maybe 2000 watts, scooters, e-bike, as application areas of wireless power, spreading out from the mobile phone, that's the established technology, into these application areas and finding really great innovative solutions. Okay, stepping back a bit to look at the technology now of wireless power and the standards there. Really just to show that wireless power is really a transformer. Picture there, you've got the ferrite core with the primary and secondary windings of a transformer. But split that in two, there's an air gap in the middle, and that's really your wireless power transfer technology. A winding that's on a ferrite and a winding that's on a ferrite with an air gap between them. And that magnetic field is concentrated in the small area between the transmitter and the receiver device. And power is transferred by that inductively coupled mechanism. And short distances, so that maybe up to 10 millimeters range. We'll see that more in other slides. And this looks a bit of the schematics. L1 and L2 in the slide there, that's your transmitter coil on the transmitter side on the left. You've got the power supply on the left, and the transmitter, the TX coil, then that air gap, and then the RX on the right, and that's your mobile device. With the load on the right hand side being your gadget, your light, your power, your battery that you're charging. And and the frequency is in the 100 kilohertz to 200 kilohertz range. And again, that short distance, maybe up to 2 millimeters. And that equation, that efficiency equation there, the two main parameters to do with the efficiency of the power transfer. There's K, that's a coupling factor, and Q factor, quality factor of the coils. So if you see in that air gap in the picture on the left, K is like that that transfer across the air gap. How effective is the coupling between the coils? And Q, the quality factor, is like a measure of the materials that are used into the coils and the system. I mentioned Q there, the Q factor. This chart, I should say there with that equation, you can see maybe with a K factor maybe of a half and a Q factor which might be 200, you can see that you can achieve levels up into the very high 90% for efficiency. And you demonstrate that with this curve here. That's the coupling factor in the x-axis there. And the set of lines showing increasing Q, increasing the Q factor, the quality of the materials that are used, and the resulting, the y-axis is the efficiency. So you can see, for example, there's a red line, Q equals 200, and you're up into the 90s, 95, 98% there for an efficiency level. That coupling factor is often related to a system which could be the separation between the coils, and the value for Q is really to do with the materials that are used, the quality of materials, losses in the system. And this chart just shows just a summary of what we've discussed. This is close coupled inductance technology. You can see the TX coil, and then the resistor, the receiver coil sitting upright. Frequencies about 100 to 200 kilohertz, and short distances, maybe up to 10 millimeters. And that technology is particularly promoted by the Wireless Power Consortium that I mentioned earlier. And they have that brand logo, that QI, they call that Qi logo. So you can see where you see that Qi logo, you know it's been tested, certified by the Wireless Power Consortium. And in that Qi standard, you have the baseline profile. That's at 5 watts. That was the original standard. And then the ambition moving to the 15 watts. And mobile phones tend to be the fast charging, maybe around 10 watts charging, trying to get as high as possible towards that 15 watts. And in the Wireless Power Consortium, those other developments that I mentioned, cordless kitchen, laptop charging, power tools, robotics, and the light electric vehicles. And the consortium, the WPC, has over 5,500 products certified, about 300 members or more. Another technology that you may have heard of is power through the air. The closely coupled technology that I just mentioned is one-on-one transmitter to receiver, short distances. And this technology tries to extend that over greater distances and perhaps more than one device. In the photograph, we ourselves have demonstrated a small system. It's a single transmitter that's powering up 3 LEDs. It's a low power system, but powering up more than one device. The frequencies tend to be ISM band or maybe RF band radio frequencies, and longer distances. In general, I tend to see lower power systems. That's really maybe based on the regulatory requirements. And that's the Air Fuel Alliance is the stronger promoter of that, and they formed from a few other organizations previously. So what is great about wireless power? Firstly, we're all living in that COVID environment, and we all want no touch, no contact. And we're in a green environment, so no cable waste, cableless, rather than the big range of cables that we had to carry around with us in my first photograph. Completely sealed devices makes for hygienic and wipe clean solutions for medical hygiene environments. No ports, no metal contacts. They tell me in hospitals that cleaning involves big disinfectants, which for metal contacts are stained or rust, very abrasive on metal contacts. By contrast, wireless power has that completely sealed, no ports, no metal contacts, and damp-proof, waterproof for the moisture or the underwater applications that I mentioned. Wireless power, proven technology. I think the Wireless Power Consortium is about 12 years old. The standard is well established with the infrastructure and safety and all the things that go with that infrastructure for public applications. And interoperability, so that a Qi certified charger, for example, you can use it to charge your Qi compatible device off that charger. The devices can work together. My device won't affect your device. Yours won't affect mine, and they can work together successfully. And safety, you can be confident that you can put your smartphone onto the charger and it will be safe, charging will be good. And should you leave your car keys sitting near the charger, they won't get too hot and burn yourself. And wireless power for convenience and for integration with Internet of Things that we'll show later on. Quite specific, this is now starting to think about, well, what does it take? What components do I need into my system, into my wireless power transfer system? These are just general points. Use the largest possible coil you have. You may be constrained by device size or something, but use the largest possible coil you have for highest transfer. Keep the distance between the receiver and the transmitter coil, keep them in the area of maximum efficiency. Misalignment is ideally the coils are placed in close alignment, perfect alignment, and choose the best combination. Really, that's dependent on the size. Keep the size to be the same. And other factors which might influence the performance, say metal contacts or buttons that might be in the area that will affect the magnetic fields between the transmitter and the receiver. I mentioned there alignment between the coils. The close coupled inductance technology is a one-on-one transmitter to receiver. And if the receiver coil is lying perfectly over the transmitter coil, obviously the receiver is able to capture the most of the magnetic field from the transmitter. Sometimes you're not able to manage that perfect alignment, and maybe other options are like this multi-coil system. Maybe, for example, in your motor car, in your car, you put your phone down on top of the charger, but you're braking and accelerating, your phone is sliding around, and this system works to identify the one coil that is the best aligned to where your mobile phone is sitting. Just one coil is activated, the software chooses which one is the best alignment to the phone. And other applications maybe are an array of devices or a tablet, a plate. Considering the alignment tolerances on the left is like best to ensure perfect alignment so that the receiver device captures as much of the magnetic field from the transmitter as possible. Angular alignment, sometimes surfaces are a curved shape, trying to get the best alignment to ensure that magnetic flux capture, and that vertical alignment, that Z, that distance separation between the coils as well, to keep it at an optimum size. This chart sort of shows the way that the efficiency, the coupling factor, falls off with distance. Just looking at the black line, the top one, you can see with a short distance, the coupling factor could be 1 there, perfect coupling. But as the distance, as the separation of the coils increase, it's falling down to the right-hand side, a value of about 0.2 or something. And then those other lines show the other lines show that if the coils are angled, that the coupling, the efficiency is not so good. All Würth coils, you have the winding, and all Würth coils have a ferrite shield behind the winding. And you might ask, well, what is that for? And these charts here are to show that the reasons for that. On the top left is the winding on its own, and you can see the red area is the area of maximum magnetic flux, going towards green and blue cooler, and you can see that the magnetic flux just radiates everywhere from that coil with no ferrite. On the bottom left, there is shielding at the bottom side, and you can see the red, the strongest magnetic field lines going upwards, and below the ferrite, the bottom of the slide, there were no or the magnetic field is much reduced. And on the right hand side is the best solution. You have at the top the receiver with a coil, and at the bottom the transmitter ferrite with a coil. And you can see the red area, the area of much magnetic flux, is focused between the two coils. There is some yellow left and right of the ferrite. That's like stray fields just at the edge of the ferrite. And the green and blue areas are all around. The ferrite then acts as two factors. Firstly, as a lens that focuses the magnetic field towards the other coil, the other ferrite, and also it acts as a shield so that behind the ferrite, where you might have your PCB, you may have electronics, you may have sensitive, say, electronics or devices, they are shielded by the ferrite behind the ferrite. So all Würth components have winding on ferrite for best performance. And coupling factor depends on the coil size ratio. I've mentioned a few times the receiver is trying to capture as much as possible of the magnetic field from the transmitter. At the top is a transmitter coil. It's a Qi certified. It's about 50 millimeters diameter, and this is showing the coupling to some example receivers. On the bottom left is a receiver. You see that area receiver to the area TX is 1-to-1. The receiver device, the active area of the receiver device, is the same area as the transmitter, so 1-to-1 size ratio, and you see the coupling factor there being 0.8. On the right hand side, the receiver device is now smaller. It's half the size, a 1-to-2 ratio, and you see the K factor has dropped down to 0.6. So showing that 1-to-1 area ratio gives you the highest K factor, like the example on the left. Going even smaller on the receiver there, the receiver here is about 10 millimeters. The area ratio is 1-to-6, and you see the K factor now has fallen from what was 0.8 originally, 0.6 in the previous chart, and now it's down to 0.29 with this big mismatch of a coil size. So that if you were designing a receiver device, the aim to make it the same size as a Qi. If you're trying to get a Qi certifiable product, you want to be the same size, or as near as possible the same size as a Qi transmitter coil, which is about 50 millimeters. On the right hand side, you can recover that efficiency by the smaller transmitter. So it goes back here to about 10 millimeters diameter on both coils. The area ratio is 1-to-1, and the K factor is higher again, 0.6 value. And just showing that the receiver coil, the sizes are important for success. A Qi, a QI transmitter is about 50 millimeters, and we look at the back of a mobile phone, you will see that the receiver coil that's behind a smartphone is at 50 millimeters, 1-to-1 size between the transmitter and receiver ratio. So we've covered quite a lot there. I'm just going to show now some of the Würth products that just illustrate what we've been discussing here. In Würth Elektronics, we have these family of wireless power coils. Transmitter coils there, that second column, that's maybe your base station, maybe your charger on your desk. The Qi sizes are 50 millimeters. The range we have here is 20 to 75 millimeter range. These are our standard offering, with maybe power going up to 400 watts and more, and with a Litz wire, a high Q factor. The receiver coils, the ones on the left column, they are like your mobile. They go into your mobile device, maybe lighter weight, maybe smaller size. So this, you can see the size tends to be a bit smaller. The power levels tend to be a bit lower. Maybe the wire is a thinner wire, because the device tends to be a portable handheld device. But a coil could be used on either side. Array coils that I mentioned help you with that freedom of positioning, so that if you're not perfect alignment, this might give you some allowance for movement. Oh, that just jumped away. This gives you just some allowance for movement there. And on the right hand side is what we call a combination coil. You can see the center is the transmitter coil, but around that you have an NFC antenna. So for example, if you're in Las Vegas at the casino all night long, you want to have your mobile phone being charged up. That's your wireless power transfer that's charging up your phone. And at the same time, you maybe want to be doing some secure banking transfer. So you want to take your winnings out of the gambling machine, transfer it into your bank account. And you could do that via that NFC data communication. So that combination coil, giving you ways of both powering up your mobile phone device and data transfer as well. Würth is the biggest range of standard coils, and they're all available so that samples could be provided to you off the shelf from our stock. Sometimes what happens is that you maybe start with a standard coil, then maybe you realize you needed some adjustment, different size, shape. The question is, does Würth do customizations coils? And the answer is yes, we do, yeah. And as you can see from our homepage, how to go about that. And one of our offerings is this 200-watt system. You may be thinking, well, how can you get started with wireless power? How can you see for yourself? How can you demonstrate to yourself? How does wireless power work? And a system like this gives you that offering to demonstrate out of the box a wireless powered transfer. You plug it in, you put on a device load, and you start to see that wireless powered transfer happening in that initial demonstration, and then maybe you're starting to think about how can you implement your specific device. This kit here gives you that framework that you can use to implement your device, hardware that you would like, software that you would like, and you can demonstrate that via this kit. 200 watts, but scalable from 10 watts to 10 kilowatts, obviously with component changes. Scalable for voltages and currents. And in wireless power, obviously, of course, the main mode is transfer of power from the transmitter to the receiver. But with this device, you also have the capability to have data coming back from the receiver. For example, a sensor, data being passed back to the transmitter through the same wireless power transfer coils back to the transmitter, and maybe back to I don't know, LCD display board or some other data transfer mainframe. I just zoom in here on this is the transmitter end with a range of components and control structures that go into system design. There's EMC protection and green in that green. So the input power is from the left. There's the resonant tank that helps to keep up the efficiency of the wireless power transfer. There's controllers in the orange. And that in the blue is that inverter circuit that's converting the DC input into the AC signal that's transferred across to the receiver device. And at the receiver side, the alternating signal coming in with the rectifier to convert it back into DC with all the controllers and the interfaces that go with that for debug and for demonstrating the data. I mentioned how, with that data being transferred across, That's from the receiver device on the top right of this picture, going back across to the left. There's an LCD board that can display the data from, say, sensors, which are in the package there. There's the sensors, data coming back through the transmitter, through the coils to the receiver, can be displayed on the sensor. And there's also a Wi-Fi module, so the data could be sent back to I don't know, control room, or your I don't know, fire control room, or whatever, the environmental control of a building, say, and through to the cloud. Information material. So a lot of stuff that we've covered there. How could you follow up with more information afterwards? There's a pretty good homepage for Würth Elektronik's homepage. Got reference designs, some of the tools that we'll discuss, our catalogs, so you can see our product offering there. FAQ page. This one, we've mentioned how to choose from transmitter and receiver coil, how to get a compatible, ideally one-to-one size. And this mix and match tool, there's the website address there. So it is a matrix of transmitters, which are the rows of this table. Transmitters this way, and receivers are the columns, so you can see, you can compare the match of coils you're looking at to see green, they are good match, they are good size match, they are good compatibility, or red probably implies the size difference is too great to make a good solution. So this then gives you an indicator which coils are a good match. And if you find a match that's relevant for you, then then it takes you to the next page, which is being able to deeper dive into the performance of that match of coils. We've now selected 2 coils there. There's one as transmitter. There's one as receiver. We've put them into the diagram, and we're showing the 2 curves, performance over frequency, inductance Q factor, and you're able to select the coils for your particular frequency of interest. This chart also shows there along the top things like size, inductance, quality. So you're able to use this Red Expert tool to be able to filter down to find coils that would be of interest to you. And on the right hand side, you've got a little equivalent circuit there. I've mentioned resonant tank a few times in passing, where having that capacitor there helps to ensure the efficiency of the system. So that gives you guidance as to the capacitor value, which Würth can supply you for matching of your system. Another good book, another good textbook, Trilogy of Wireless Power. Funnily enough, it's in 3 portions. The first one is basic principles, like some of the things that we've discussed today. Another chapter, another section on wireless power transfer systems, and then on applications for wireless power. So that's a good, useful textbook on the subject. And just things about Würth Elektronik. We've got the biggest available range of standard coils, and I should say those are available from stock. They were available to you for sampling, so that if you can get in touch with your Würth contact, they can supply you samples. So we've got that biggest range of standard parts available to you, and then we also do those customizations should there be something specific that you want for your system. High performance, high quality product line, high volumes, and those great tools that I've mentioned, mix and match, Red Expert for that tool, for that component choice, and that trilogy book as a guideline for designs and for methodology and processes. So lots of interesting ideas out there. I just finished with this me being a cyclist, it's just like showing the range of innovative designs that come with wireless power. Here's a new e-bike design, and here the innovation is to take the e-bike battery up to the handlebars so that you could have your mobile phone being charged. So as you spend the day with your GPS, with your, I don't know, Map My Ride or Strada or whatever calorie count as you cycle, you're able to show that. So just to illustrate the really innovative set of solutions that are out there. Big range of applications from consumer, medical, industrial, kitchen, robotics, up to automotive vehicles and electric vehicles. 200-watt kit gives you a great starter for getting up and going with wireless power. And Würth is able to help you a lot with samples and provision of materials to help you in your design work. So hope that helps. Wireless power transfer, I say great fun, many great products out there, many great opportunities, and I hope that that encourages you to explore further with what you may be thinking of for new applications, new products. Thank you very much.
Thank you, David, for presenting today's Würth Elektronik webinar. We're now going to turn it over to our questions. We do have a few coming in here. Give everybody a little bit of time to go ahead and ask your question. We're going to start off here. Now, you mentioned the cordless kitchen, the key spec. When do you expect cordless kitchen appliances on the market?
That's great. So cordless kitchen has been in development for a while. It's getting very close to the spec being finalized. I think that will be this year, and then next year will be the products coming to market. Then next year, so it's been a while coming, but it's getting close. And I think next year is people are starting to build up now the infrastructure, the technology development in their product developments to support that for next year product launching.
And I'm looking forward to it, much like I'm looking forward to that bicycle that you just showed. I'm a cyclist. I pulled that picture up. I did this. So I'm ready for it. And so our next question here. I would like to have a small appliance about 1 watt. Can it be Qi compliant?
Hey, that's a good question. I mentioned Qi is the 5 to 15 watt range. That's like the mobile phone range, and also consumer devices within that range. So the question then is, can you apply that Qi to something that's different range, be it lower or higher power? And I think probably the best way of doing it is that you can use the same infrastructure, you can use the same IC controls and software controls and safety, although you're probably using it outside what Qi is designed for. But you're piggybacking on all that technology and infrastructure that's in place to help you in your application that's maybe got a different power level from what Qi formally supports.
Thank you. Now, you mentioned RX, receiver coils, TX, transmitter coils. What are the differences between those?
I mentioned ideally a solution would be one-to-one. The TX and the RX coils would be exactly the same size, so that the magnetic field would be captured brilliantly from one to the other. So that having the same coil on both sides would be great. But a receiver device might be a bit smaller. You might want to have it in your hand or in your pocket or wear it on your wrist or something. So it's probably a bit lighter than the TX coil, which might be designed to sit on your bedside table or your desktop or something. A bit higher. The TX would be a bit higher Q factor, maybe thicker wires, lower losses in the design. but the receiver, you want it to be something light that you can carry around comfortably, so probably smaller, lighter, but they can be used on either way. I guess an ideal would be having a TX coil on both sides, but it may be a weight consideration or a cost consideration or a size consideration that means you might want something different, slightly different on the other side.
Thank you very much. You said that Würth has a very big range of coils, maybe the biggest range available. Will some of these coils actually go obsolete, and how can they get samples?
These are great questions coming in there. I mean, those are fantastic questions. Yeah, I think in all my knowledge of Würth, I don't think we obsolete any products. I think they're always there. They're always in our stock. So I don't think there can be the concern that a stock wouldn't be available for the lifetime of your product. And in terms of getting samples of a part, say the parts are all in stock. They're already available to a request, so that if the person has a Würth contact, or also on that homepage, that wireless power transfer homepage that I mentioned, there's that address as well if they haven't a Würth contact at the moment, and we can arrange that.
Okay. Now, this one is considering the shape of the coil. A lot of our pictures here, they showed the round shape of these wireless power transfer coils. Can they be any shape? Do they have to be round?
Oh, that's another great question coming in there. I think most of them are round. I guess probably because it's easiest to simulate and that sort of thing. But your receiver device could be in any shape. It's a little small, I don't know, maybe a tag device or something. So it's the shape of the device that is almost defining what shape the coil has to be to fit in the device. So it could be, say, it's the gadget, it's the plastics, it's the housing of the device that may drive a different shape for the receiver.
Absolutely. Now, do you realize solutions which include data transfer? I think that this is actually something that you covered towards the end. So do we have solutions that include data transfer and smaller coils for power?
I missed the last bit of your question there.
Along with, do we also have solutions that include smaller coils with lower power?
Yes. So first of all, for the data transfer bit, I mentioned there that 200 watt kit, and also we've got a 15 watt kit. So in the main, the systems are delivering power from transmitter to receiver, but the receiver device might be a sensor that you're wanting to pass data back. And I demonstrate in that 200 watt kit how the data could be transferred back to that LCD board display. And there's a great app note that discusses how that's done. So again, point to that person to that homepage with that app note that describes how it's done. I think that was the first part of the question, and the second portion is a low power device, low size device.
Yes.
Yes, and I mentioned there, like there's some coils which are like earbuds, or maybe a 6mm diameter, maybe 1 watt audio devices. So there's that whole very small in that range as well, in the Würth product offering as well.
Thank you very much. We have time for a few more questions here. This one is pretty specific to the United States. What are the regulatory considerations for wireless power transfer? Say, for instance, for the FCC in the United States, with regards to power levels and whether or not there are communications between the transmitter and the receiver, or just power transfer. So I think they're asking about the regulations for data transfer.
And that is a fantastic question. And in fact, I think it's so good that I think we should tell the person next week in the advanced course to pick that up, and I can cover that in detail. It's quite a detailed question, so I don't think it's an easy answer. And we'll get the person to cover it in next week's tutorial, or next week's webinar, if that's good for the person. Or also contact me separately, and we can give the detailed an answer to that question. But thanks for that question. It's certainly I mentioned like the frequency range being 100 to maybe 100 and 200, but all that's constrained by the regulatory areas that can be worked. So it's a detailed answer, probably too much to give a quick answer just at the moment.
Yeah, absolutely. There are a lot of regulations both in the United States and outside the United States.
Yes.
We have to go into detail, which is perfectly fine, and we will make sure that we come separately on that. So this next question, there are actually two questions here. Even when the tank is shielded, is EMC, both radiated and conducted, difficult to manage in surrounding circuits?
The ferrite is great for that shielding. So that the ferrite provides a really great shielding. But in addition, if there's something in particular that you're concerned about, maybe extremely sensitive electronics of your board or something, there's other techniques that Würth can use in addition, be it a bit more ferrite sheet or something that could be around your very specific electronics. But with that good design, you're able to meet the EMC requirements and certify your device. So it's good design practice and with ferrites and maybe any other shielding if there's something that was specific to your electronics.
I agree, and Würth Elektronik does have an extensive amount of shielding products available both for heat and EMI. So of course we can include those links. You can complete your design using Würth Elektronik components. We'll make sure that we do include all of that information in the follow-up email for you. The second question here, what are some of the long-term health effects of human exposure to high power fields?
When you say high power, I guess I'm not quite sure what you might think of. For example, is your question related to the mobile phone that you use in your pocket or the Wi-Fi that you use? So there's fields around us. Specifically in wireless power transfer. As I said, it's a close coupled, very short distances, like 10 millimeters, and it's constrained by the ferrite behind the coils. So any magnetic field is very much constrained within that very small gap. So really, if you're thinking about human exposure, well, say the magnetic field is in that tiny gap between your devices, like between your mobile phone sitting on your charger on your bedside table. So it's not fields around the room. They are constrained with that device. You may be thinking of some other applications that power through the air that I mentioned, where maybe they think of greater distances, more devices, greater distances. I think it's been more constrained to being low power devices, so that might only be, I don't know, 1 or 2 or 3 whatever watts. So it's trying to satisfy that regulatory requirements by such low levels of power to I don't know, human body absorption and that sort of thing. It's very low power levels to meet that regulatory requirements. If that's what the question meant when you said high fields, maybe you're thinking of something else. Maybe you can follow up with an email just to explain what specifically you meant.
Absolutely. And of course, if you have a question after this webinar, simply feel free to reply back to our follow-up email that will include a link to the presentation materials as well as video on demand. And that'll come from webinarteam@we-online.com. We have time for one more question here, the last question. Do electronic components not related to Qi charging need to be shielded from the inductive charging area to avoid unintended behavior?
Again, it's a similar answer that I just did. But with that ferrite behind the coils, the magnetic field is very much constrained in between the coils. So you may have a PCB or something, but it's shielded by that ferrite. Perhaps there's a bit of stray field at the edge. Again, as we mentioned there could be some other ferrite shielding that you could apply if it was something particularly sensitive. You might be thinking of, if you set your car keys down beside the field charging, does it get hot? Part of the Qi environment sort of like looks at that to see if there's any other spurious effects, if there's data being lost that could be being used to heat up something that shouldn't be. So there's that safety features built into the Qi protocols and software and handshaking that are looking out for spurious effects. Again, I'm not sure if that answered your question fully. You can contact me afterwards if I didn't get it all.
I think it was fantastic. Thank you, David, for presenting and for joining us for today's webinar.
Thanks, Amelia. Thanks, everyone. Hey, and wireless power is fun. Wireless power is fun, so hope you enjoy it with their new investigations and implementations and things.
It really is. And the thing that I like about wireless power is it's constantly changing. We might have maybe the same title of the webinar, but the content is completely new year after year. So it's always great to have your team come in and present this to us. Thank you very much.
Thanks, Amelia. Thanks, everyone.
And thank you, everybody, for joining us for today's Würth Electronic webinar. Again, if you have any questions, if we didn't get to them now, we will get to them and we will email you personally. Simply look for the follow-up email at webinarteam@we-online.com. Also remember to follow Würth Electronics, or you can follow myself on LinkedIn to learn about all the upcoming events and webinars that we have. Our next webinar will be, of course, next week. It is our Advanced Wireless Power Transfer course on the 15th. And for all of those going to APEC in Houston, Texas in a couple weeks, make sure you stop by the Würth Electronic booth, number 644. Grab your Würth Electronic hat, as well as an invitation to the Tuesday party. Again, that is the Applied Power and Electronics Conference in Texas, coming up in just a couple weeks. And don't forget to listen to the new Würth Electronic What's Up radio podcast, where we are bringing our application notes, our blogs, our press releases, and our webinars to an audio format. This week's episode is Sensors in the Change of Time, and you can download that complete episode Thursday at 12 p.m. Central. It's the What's Up radio podcast, and you can find it on all podcast streaming networks such as Google Podcasts, iTunes, Spotify, LinkedIn, Facebook, and so much more. So I'm Amelia Thompson. I hope to see